right, our next presenter is Brehima Kone. Brehima, if you would share your screen. This presentation is called Time Series Forecasting Using Deep Learning, and the advisor is Dr. Nian Zhang. Brehima, are you with us?
Yes.
Okay, it's all yours.
Can you hear me?
Thank you.
You guys can see my slide?
Yes, we can see your screen.
Okay. My name is Brehima Kone. I'm at study at electrical engineering. So I just graduated. So today I'm going to talk to you about time series forecasting using deep learning. Yeah. First time series data using a long short-term memory or LSTM. So this project is to explore how to forecast time series data using a long short-term memory. So the activity here will include forecasting the value of a future time step of a sequence by training sequence to sequence regression LSTM network, where the response as a training sequence with a value shift by time step. The LSTM network learns to predict the value of the next time step at each time step of the input sequence. The forecasting value of a multiply time step in the future. And then third, apply the deep learning based time series prediction in some application, such as chickenpox prediction. That's my data here. So what is a deep learning? So deep learning is currently extremely active research area in machine learning and the pattern recognition society. While the big data offer great potential for revolutionizing all aspects of our society, harvesting of valuable knowledge from big data is extremely challenging task. The large scale and rapidly growing information hidden in the unprecedented volume of no traditional data required to develop and decision-making algorithms, as well as interdisciplinary team working in close collaboration. So deep learning refer to machine learning technique that use supervised and or unsupervised strategy to automatically learn hierarchical representation in a deep architecture or classification. Company like Google, Apple, and Facebook, who collect and analyze a massive amount of data every day, has been aggressively pushing forward deep learning technique. Next slide. So why time series forecasting? Time series are looking data over time to forecast or predict what will happen in the next time period based off a pattern or reoccurring trend from previous time period. We know history often repeats itself. So whatever even happened in the past, they are likely to happen again in the future. So the most common basic example of a time series is a seasonal sell. Revenue go up and during of a season and the sale go down. So this is not hard to predict as we can almost expect what is come every holiday. But we can also get either time based off a trend in our data, such as consistent upside trend or improvement in the company performance over time, or downward trend, what is consistently falling each year or month or day. Whichever time period we can interesting in. So here, what's make a time series forecasting different to other type of prediction model is that prediction is based off in giving time, looking at a sequence of observation over time. So a time series forecasting can give us a better estimate figure for how much it could continue. So time series data. A time series is a sequence of a data point of record through time. Those when dealing with a time series data or their model, especially value in time series expressed, express a dependence of a time. So consequently, if we change the order of a time series, we may change the meaning of our data. Generally, time series data have two important properties. Data is measured sequentially and equally spaced in a time. Each time unit has a most one measurement. So in addition here, we doing time series forecasting, we usually two goals. First, we want to identify pattern that explain the behavior of a time series. So second, we want to use this pattern to forecast and predict new value. So time series pattern here. So most of the time data user we have at least one of those three kind of a pattern. You can see first trend. So trend describe the general behavior of a time series. Manifests a positively long-term slope over time and has the uptrend instead of describe in general negative slope, it has a downslope. So overall trend, I'm sorry, I didn't. So this is a graph of a trend. So it may also change the direction. Like you see, they can be up to downtrend, up, and a stationary horizontal trend, a defined time series with neither positive or nor negative long-term pattern show this figure one here. So next, that's a seasonality. A seasonality is any kind of fluctuation change in any time series caused by calendar or related event. This event can be the time of a year, like a winter or summer, or time of a day or week. Seasonality always has a fixed frequency. That is a seasonal pattern always start and end in the same period of a week, year, etc. So cycle. A cyclical pattern is a time series kind of a change that is not related to seasonal factor. These are rise of fell with no fixed magnitude that can last more than a calendar year. Cyclical patterns are not repetitive. Usually they result from external factors which make them harder to predict, like you can see in a figure. So forecasting method usually make advantage of this pattern to produce reliable prediction. Like you see below, you see here, the time series data for sell a new single family house in the US, not with strong seasonality. House sales are normally slow and beginning in the year. Peak occur around the month of June. You guys can see.
Yes, we can see your slide.
See, okay. So there are strong cycles that may range from 6 to 10 years and mentioned in a figure two. So this is my data. So the chickenpox data contain a single time series with a time step corresponding to month value corresponding to the number of case. The output is cell array where each element is single time step. So before that should okay. So anybody who doesn't know, like a chickenpox is a kind of disease. So like we living in a difficult time now. So like COVID-19, chickenpox also is like a disease. So like we said in a preview. So what we do, we collect the data. Like you see the cases here, and then we see the month. First, what we should do, like we say, time series forecasting, we collect the data and then we predict next month or next year or in the future. Like so so the partition of the training data trained first 90% of the sequence and the test of the last 10% here. So for a better fit and to prevent a training from diverging standard, the training data to have a zero mean and a unit variance in the prediction, you must standard the test data use the same parameters as the training data. So that's my result. So that's my what I collect. So I will be able to show you guys my MATLAB so we can see the code. I will just like I work. So train LSTM. So let's see. Prepare prediction and response. Forecasting the value feature time step of sequence specify the response to be training sequence with a value shift by one time step. Each time step of the input sequence, the LSTM network learn to predict the value of the next time step. The predictor are the training sequence without the final time step. So creating an LSTM aggregation network specify layer to have a 200 feeding units. Like you can see this graph. Can you see this?
Yes, we can see it. If you could close in about a minute, please.
Okay.
Thank you.
So future time step. Forecasting value for multiply time step in the future. Use a predict update state function to predict time step one at a time and update network state each prediction. For each prediction, use the preview prediction as input to function. So like you say here, the blue one is observe, and then the red one is a forecast. So this our data into training and test data, we can popular machine library queries, skitch-learn, and partner to do this. We can just take the last day value of our training sets and use and estimate the same value of the next day. So we use like a square error model. It's allowed to us to compute error between our prediction and the testing data sets, which are real value for all the data point we predict here. So we can compute the root mean square it will output and a scale value as you can see the value here. That's a pretty bad. So we can do better. So to improve our sample average approach, but only taking the average of a value for last time period only. See that we can are getting better prediction and our error is a smaller, like you see here. Okay. So here our RMS is a 183.4475. So when we take a square root, you see, from a 183.44, we come out to, you see, the RMS is come to 136.16. So this is time series forecasting. So this is area machine learning. It's often neglected and important because there are so many prediction problems that involve a time component. This problem are neglected because it's time component that make a time series problem more difficult to handle. And so before I acknowledge more, I want to see if I can share my MATLAB so you guys can see the code, how I work on with this code. So please, 1 second. Share. Let's stop this. You guys can see?
Yes, we can see the screen.
Okay. So this is my code. So yeah. Sorry, just few seconds. It's coming. So it's gonna take a few seconds. If you guys have any question, so you can ask me before this.
Yes,
Hello.
please go right ahead.
Okay, yeah, just very quickly. I just have this one question.
Okay.
So what was the purpose of this deep learning algorithm? Like, what was the purpose again?
The purpose is to predict. So from time series forecasting, we use in many stuff today in a finance, in like a small business, and
Yeah.
for like let's see, for like a we now is like a COVID-19. So
Okay.
you can take data from like the last 2 months, and then you can predict for the next 2 months what will happen, how many people is gonna die. So or how many people are gonna have gonna get like a COVID-19 based off of your data, like your preview data. You just collect like a time series forecasting is only like you collect what you have it, and then you can predict the future.
Okay. I guess
Yes.
just a quick follow up here. So how is this? If you know, like, how is this like different from other deep learning methods? You know, like artificial neural networks. You know, stuff like that. You know, I'm not an expert here, but How is it different? Just
So,
curious.
so the difference here, like, let's go back to slides because I mentioned, I don't know if you catch that 1 second. So let's see the difference. Like I said, the difference like for time series forecasting, it's simple to use. So the only things you have to do is to collect the data based off of what happened. That's like you said, like on my preview slide, I said what happened today may happen in next year or in a few years.
Okay.
That means like you predict what's gonna happen based off of what are you living now or what are you living before.
Mm.
Can I ask you a question? So
Okay.
you apply the deep learning to time series prediction. Have you think of this? What application do you think you can apply to the time series prediction? What applications for your
Yeah,
research?
use a MATLAB. Use a MATLAB here. So and so what I use a MATLAB and then we can use a popular machine learning library called scikit-learn and append that to this.
Okay, so maybe water quality and quantity prediction for the financial applications.
Yeah, we
Or
can
the,
use it
yeah.
for financial application.
Mm-hmm.
Yeah, you
Yeah.
can because I can say like I said, Google used today, Facebook used. We can take example for a Uber. Like that's a seasonality. Like when I take a Uber, that's like how Uber predicts. So when it's like a game or like let's say seasonality or just like a bad weather or just like a good weather. So that's like a or Uber use to predict like how it's gonna be. So that's why when you look at a Uber map, you see like the price high or just like it's down. It's a base of a prediction they make it. So they know.
Okay.
Yeah.
Okay, thank you.
Okay, you're welcome. Now today is like it's a big thing. It's a lot of just like a company use like time series forecasting. So
Okay, I think that was a wonderful presentation. Thank you so much, Brehima Kone.
you're welcome.
Yes, thank you.
Well,
Our
yeah,
presenter,
I don't know if I share this. 1 second. Let's see the things.
our next presenter is Victor. Victor, could you just check the chat that real quick to see my note to you? And
So I would like to thank a mentor like Dr. Zhang for her supervision and continuity to support like Martin finding in the research fellowship program and the School of Engineering and Applied for Science. Okay. So thank you, everybody. So
that's excellent. Thank you so much, Brehima.
you're welcome.